At the end of last video, I asked you to give it an expression for cos of 4 theta in terms of powers of cos theta, and the same for sine of 4 theta, but there'll be a cos theta there as well because you can't simplify that. These are the answers to that, so hopefully you got those. Just going to move on slightly. So use de Morph's theorem to express cos of 5 theta and sine of 5 theta in terms of cos theta and sine theta. Hence find an expression for tan of 5 theta. Okay. Hence find an expression for tan of 5 theta. So using the same thing again, we're going to say z, a complex number, is equal to c plus is. Okay, where c is cos theta and s is sine theta. I'm going to do z to the power of 5 using the binomial expansion. Is going to be cos to the 5 plus 5 cos to the 4 si minus 10 cos cubed s squared minus 10 cos squared s cubed I plus 5 cos s to the 4 plus s to the 5i. Okay, it's using the binomial expansion and simplifying I squared to minus 1 where I can. Using de Morph's theorem, this is completely identical to cos of 5 theta plus I times sine of 5 theta. So because z to the 5 is equal to that and equal to that, then these two therefore must be completely identical, and we can equate the real and the imaginary parts. So looking at the non-coefficients of I, the real part, we're going to get cos of 5 theta is identical to cos to the 5 minus 10 cos cubed, cos cubed of theta, sine squared of theta. That's imaginary, this one is the next real one, so plus 5 cos of theta sine to the 4 of theta. And I'm going to leave it there, I'm not going to simplify that any further. Okay, we could get rid of these signs, but I'm not going to. Because the question says to leave it in terms of cos and sine, so that's fine. Also going to do the same thing with sine of 5 theta. So I'm now equating the imaginary parts, the coefficients of I. Here I'm going to get 5 cos to the 4 of theta sine theta. That's real, that's imaginary, so minus 10 cos squared of theta sine cubed of theta. That's real, and then finally that's imaginary, so plus sine to the 5 of theta. And again, I could use the identity cos squared plus sine squared is 1 to get rid of this cos squared and to get rid of this cos to the 4, but I'm not going to. Okay. So I can now use that to find an expression for tan of 5 theta. Okay, this is what the second part of this question asks. So tan of 5 theta is going to be equal to sine of 5 theta divided by cos of 5 theta by the definition of tan. Okay. I'm going to go back to my shorthand notation. So that's going to be 5c to the 4s minus 10c squared s cubed plus s to the 5 divided by c to the 5 minus 10 c cubed s squared plus 5c s to the 4. Okay, so that's just using these two definitions here. In this, and c is cos theta and s is sine theta. Now what I'm going to do is I'm going to times top and bottom of this fraction by 1 over cos to the 5 theta. Just to get rid of these coses and sines, and that's going to give me lots of tans in their place. So the cos to the 4 here will cancel with 4 of those, and that's left me with sine over cos, which is tan, so that's 5 tan there. Those two are going to cancel with 2 of those, and the other 3 are going to combine with that to make a tan cubed, so it's minus 10 tan cubed. And the 5 sines are going to combine with the 5 coses to make 5 tans. Similarly on the bottom, that's going to be the number 1. That's going to be tan squared, and that's going to be tan to the 4. So therefore, tan to the 5 theta is identical to 5 tan of theta minus 10 tan cubed of theta plus tan to the 5 theta, all divided by 1 minus 10 tan squared of theta plus 5 tan to the 4 of theta. And there is my identity for tan to the 5 of theta in terms of powers of tan. Notice that on the top of that, all of them are odd powers, on the bottom are all at even powers. It's fairly common to have that kind of pattern on these tan identities.